All right, well, I'd like to welcome everyone today here to another ESCoE research talk. We have Nanditha Mathew and her co-author Emanuele Pugliese to give a discussion about positioning firms along the capabilities ladder. To introduce myself, my name is John Morrow. I'm at Queen Mary, University of London, and affiliated to ESCoE. I'm here in London. Nanditha is over in Europe, which we miss dearly over here in London. She's going to talk about some of her expertise, which is on not only firm capabilities, but the implications for growth. And here, there's a lot of measurement issues because trying to actually assess what kind of capabilities implicitly have can be quite tautological in the sense that we only can observe the capability often after the firm does something, performs some action. So Nanditha's got a really interesting paper looking at some very unique data, trying to disentangle some of these forces. And then to discuss it, we have Anthony Savagar, who's an expert on firm dynamics and macroeconomics, who also has connections to the BEIS and the ONS, both with measurement issues and practical applications for questions like this. So I'm hoping we're going to have a nice discussion after that for 10 minutes at the end, and we can think about some of the measurement issues and other queries that have been brought up by the two speakers. So with that, thank you very much, Nanditha. The floor is yours for the next 40 minutes.
Yeah, thank you so much, John, for the invitation and for the introduction. So, as John said, I will be presenting this work. Full screen, yeah. That's it's available as a working paper. The title is "Positioning Firms Along the Capabilities Ladder." It's co-authored with Emanuele, who is here, who is also at the UNU Merit in Maastricht, and Alex, who is a professor at the Waseda Business School in Tokyo. So what we try to do here, as John was saying, is trying to capture or trying to put some numbers into what are the capability structure of firms, how does it look like, and how are the capabilities structured in the sense of if there is a natural order in which firms do certain activities. So I would start talking about what are firm capabilities, its relevance to the management literature, to the development literature, and the issues that are there to measure them. And then we will see, I will show you some of the methods that we use to rank these capabilities and what does it mean by this ladder and what it means for firms to be at different stages of the ladder. And then I will give you some concluding remarks. So first, let's start talking about firm capabilities. If you look at or if you're quite aware of the management literature, it's since quite some time that we talk about a resource-based view of sustained competitive advantage. The fact that firms have, it could be idiosyncratic characteristics or intangible resources that help them to have a sustained competitive advantage in the market. It started by the work of Penrose that talked about the excess resources. Then this was continued by the work by Tees, who talked about dynamic capabilities. Why dynamic capabilities? These are capabilities that are that have the characteristics that is not tradable, in the sense it's not that one firm can just decide to sell these capabilities to another firm. It is difficult to imitate. If another firm does something, does not mean that I can do the same. And the same way, it's also hard to observe. And if you also look at the evolutionary economics literature, it talks a lot about firm heterogeneity, how things are done at the firm, emergence of novel practices, the importance of tacit knowledge. And the tacit knowledge is what actually that limits the development or replication of these routines and capabilities. It also talks a lot about what firms can do, because in the end, what a country can do, likely in terms of the production, depends on whether there are firms in the countries that can do certain activities or produce certain products. And what a firm can do is very much constrained by what it is currently doing or what it is able to do. A definition of capability that we use here is the ability to perform an activity using a set of resources. So the question is, how can we try to infer the capability of a firm given what we observe in terms of the data and the balance sheet. Now, I talked about the management literature, but also in the development literature, the importance of managerial capabilities of firms or capabilities of firm have had quite some relevance. If you are aware of the work of Sirera and Maloney in 2017, which is the innovation paradox, it's a monograph that was published by the World Bank. So the paradox that they pointed out was that even after saying that advanced economies spend on innovation, spend on R&D, innovate and grow, still emerging economies spend much less on R&D. So why this paradox? They also give some answers to it. It's because most of the firms or the countries that are in the stage of development that are lower than advanced economies do not have the capabilities to do R&D or to do innovation. So they give this picture that I show here. They call it the capabilities escalator. What they argue is that the innovation policy needs differ depending on the stage of development. So if you are in the incipient NIS, National Innovation System, what you need is more of building managerial and organizational capabilities. You need to develop STEM skills and engineering, and then you move to the mature national innovation stage, where then you can start thinking about R&D projects, investments in R&D, because you already have some capabilities that will help you to benefit from these R&D. And then you go to the mature national innovation system, where you can think of long-term R&D projects, patenting, and so on. Much of these activities are done at the firm level. And what we try to see here is if there is some kind of an order of these kind of activities also at the level of firms. Going back to measuring capabilities, when we start talking about, okay, we want to look if this kind of structure is seen in firms. So there is an inherent problem also with the vaguity of the definition, that it's very difficult to observe these capabilities that we are talking about. There have been some studies. There are qualitative studies. So quantitative studies, of course, as I said, have the problems of measurement. Qualitative studies, there are problems of reliable and objective identification of real capabilities. At times when you do surveys, self-reported data also has problems in the sense of it's not really at times comparable between firms. It depends on the perception of the informant about certain kinds of capabilities that are in one firm that could be very different from some other firm. And mostly it's done for specific sectors or specific industries. What we try to do are the red boxes. So we try to have a quantitative analysis using objective data that would somehow cover the majority of the sectors. So what we do here, our approach, we would focus on the inputs. So the idea is that if there is an initial allocation of resources into a capability development, then it can be used as a proxy for actual capabilities. It's difficult to, let's say, see the ability to perform. I mean, it's quite pretty much unobservable, but it can manifest through the spending on certain activities. So for instance, buying a violin would be taken as evidence of a violin playing capability. Now I give some, let's say, as an analogy to the R&D capability, I give some examples to show what we mean here by input and intermediate and output. So let's take the case of the violin playing capability. So what we argue is that, okay, what would be an input here? An input would be, I buy a violin. So similarly, for the R&D capability, the input would be spending on R&D expenditure. So our assumption is that if I spend on R&D expenditure for 3 years, this means that I know how to do research and development. An intermediate step for this would be, for the violin, would be, let's say I pay for the delivery of a certificate that confirm passing a violin exam. For the R&D part, this would mean, well, for the innovation, I pay application fees for a patent. One could also think of like output. What would be the output of the success of the capability? Well, you have an audience that is satisfied. You play violin, and for R&D capability, this would mean commercial success or grant of a patent, or you're able to make a product that is successful from the innovation or from the patent that you have generated. We have in this, we have mostly inputs, we have few intermediate and output as well. So what's the data that we use? The data comes from the balance sheet information on Indian firms. It's called the Profits data. It's provided by the Center for Monitoring Indian Economy. In our knowledge, this is one of the biggest databases that's available for India, that where we can track firms in time. There are other databases like the plant level databases that I believe also John has used. Here we have around 45,000 firms. The time period analysis will be between 2000 and 2020. We have both manufacturing and service sector firms. As I said before, we will use inputs. So we will see if firms have spent on different dimensions, and we have 47 different dimensions. So to see the capabilities of firms in these 47 different activities. So now we get the second part, the hierarchy of the capabilities. So before getting to the hierarchy, I will explain to you the concept of nestedness, which maybe some of you are already aware. First, the concept of nestedness appeared in biology literature, the idea that the capabilities that are required for advanced ecological niches were nested in the more basic ones. To give the example, I think the first paper showed the example of honeybees. So the honeybees that were able to, let's say, extract nectar from a complex flower. Complex flower would mean a flower that is, let's say, on top of a tree that is not easy to reach. So if you are able to take nectar from a complex flower, this means you would need strong wings to fly and strong beak to open. And if you're able to do that, the bees were also able to take nectar from the simple plants. So this is the idea that if you're able to do a complex activity, you can also do a simple activity. If there is this structure, then we would call this as nestedness. And we can actually empirically see the number of, see a number that will test the nestedness and tell you how nested is the system. So if you see, this is in these three different pictures. The first one is quite nested, it's measured with the temperature. So if you have the capability for doing this, this means that you can also do these activities. The second one is not so nested, and the third is not nested at all. Now we will see how it will look in our data. Yeah, so nestedness has also been actually seen in patterns not only in biology, but also in economics. There are studies that have shown that countries that were able to export advanced products were also exporting basic ones. And there are studies also by Manuele that showed countries and regions patenting in advanced fields, also patent in simpler fields. So what we do here, we use a data-driven approach to simultaneously measure both the ranking of the advanced activities of firms. So advanced activities of firms, what are those? The activities that are not accessible to firms that are not complex, so not high enough the capability ladder. And we also, at the same time, look at the position of firms in the ladder. So here, it's a variation of the algorithms that you have seen in the complexity literature. Here, the fitness of a firm is basically the weighted diversification of the firm, weighted by the complexity of the activity. At the same time, the complexity of the activity is the inverse of the weighted ubiquity of the activity, which is also weighted by the inverse of the complexity of the firm. So to put it in simple words, an activity is complex not if a complex firm does it, but if there is no simple firm that is able to do it. And what we have to do is we have to see a fixed point for both the equations. And as I said before, which is the data that we are using, we are the Indian data, and we have 47 different activities for the firms. We started the analysis by using binary variables for capabilities. That would be For instance, half the firm spend on R&D, half the firm spend on software expenses, and so on. Later, now we also have, as part of the appendix of the paper, that we also use at the values. So the results that I show you are, we use binary variables, and we also categorize these variables into 3 different sections. So the first one would be basic production, managerial, and organizational capabilities. Some examples of the variables that would go in there would be if the firm owns a plant, if they have spent on transport, if they have spent on advertising, marketing. And for internationalization and absorptive capacity, the variables would be, have the firm spend on R&D, is it exporting, importing, does it have import of, we split this into many different variables, import of machinery, import of raw materials, and so on. And then the last stage would be more innovation, so patents, product development expenses, and so on. So these 3, let's say, categorization are just, made to somehow see the 3 steps that we saw before in the Sierra-Ramaloni. But this kind of classification is something that we have done. It doesn't really matter if we classify the variables in these 3 ways or not. So to tell you how the matrix of firm activities would look like, this is a matrix of firm activities with the raw data that we start with. So the different colors are the different activities. So the red is production. So all the variables that I said that are related to production, if the firm spends on it, then there's a color. So black is managerial and organizational capabilities. And here the columns are the different activities and rows are the firms. So you see that black and red are much more colored, in the sense that there are much more firms doing these 2 than the others. So this, you can actually see it as a, like a Excel that we start with. So we have put the colors nearby, but this doesn't mean anything. I mean, it's just to show you that the colors, some colors are much more prominent than others. And now we run the algorithm that I showed before. And what do we get? So just to quickly go back, what does the algorithm do? What the algorithm does is, at the same time, it rearrange the rows and the columns in such a way that the firms that do, let's say, the complex activities are moved to the right, and the firms that do simple activities are moved to the left. And it's the opposite. The firms are moved, the complex activities are moved to the right, and the simple activities are moved to the left, and the complex firms are moved up, and the simple firms are moved down. So what we can see here is that you see that all the colors are moved to one side. There is a triangulation of the matrix. This is the first thing to note, which means that there is strong nestedness in the system. Now let's zoom into the second picture, and we can tell much more things. First of all, so these are the complex firms doing the complex activities. If there are complex firms doing complex activity, it also means that you see that they also do the other activities that are before. At the same time, we also see that there are certain colors that come first. So for instance, production and managerial are somehow in the first step. So we put these 2 lines to also kind of demarcate the 3 different categorization that we have done before, that actually we see that it is a natural outcome of the algorithm. So if this is a natural order, we see that there is a strong natural order in which the firms do these activities. So the firms first do production and managerial, and then they start doing R&D, trade, and then more advanced activities like innovation and so on. Now, we see here that there is a nestedness. Now, how nested is this? So we want to understand, we want to put a number to how nested is a system. Is it something that we would observe if we just take a random matrix or not? So this is something we want to see. How rare is it to see this kind of, or how rare or how common is it to see this kind of nestedness pattern? So what we do here, we take the help of null models to test the nestedness. What we do is we create a bunch of matrices. We rearrange the rows and the columns in. So the characteristics of the, we shuffle the rows and the column. The characteristics of the rows and the columns are very similar to the initial matrix in the sense that there is an expected level of diversification. Firms do diversify in different activities, and also some activities are more simple, some activities are more complex, but we don't know which activities are, this part is random. And what we do, we calculate the nestedness of all these random matrices. And we have the distribution of all the nestedness that we get with these random matrices. And this blue histogram is, this is the density, this is the distribution of all the nestedness that we get from these random matrices. And the red one is what we observe, that is 0.7. So you see that in a random matrix, the nestedness would be like around 0.2. So this is quite significantly higher than empirically what we observe, which means that the nestedness that we observed in pictures, it's also, we see this also in numbers, that there is a very strong tendency that there are certain activities that are prerequisites for certain others, and that firms do this in a natural order. Now, how does it look like in time? So what does it actually mean, a complex activity in time? So to give an example, of course, the blue, that is innovation, is high complex in 2002, and it's also a high complex activity in 2020. But if you look at something like IT and communication, which was a high complex activity in 2002, meaning that there were less firms doing this activity, it's much more common. It's let's say a simpler activity in 2020. Likely when you start a firm, you first start having a website and so on. So it's no more a complex activity in time. So even though the complexity of the activities stay more or less similar, there are some changes as well. And now we see the firms and the ladder, what it means to be at different stages in the ladder. First, we look at how does the firm capabilities look by industries? This is the first question that comes to our mind. I mean, which are the sectors in which we see higher firm capabilities and so on? So here, the different letters that you see on the left are different sectors. C is manufacturing, D to F is energy, water, construction, and so on. We have the mean, we look at the deviation from the average capabilities in the economy. So there are three sectors that have higher average relative capabilities, that are manufacturing, J and M. And J would be ICT, and M is professional, scientific, and technical activities. So these firms in these sectors have higher relative capabilities. Here, the circle means, circle is the number of firms, so how big is the sector? What we do is we see that the C is pretty big, the manufacturing is quite big, and we want to split it and see how it would look for, let's say, different kinds of manufacturing sector. So that's what we do next. And how do we split it? We look at, let's say, like the Pavet taxonomy. The Pavet taxonomy is an old taxonomy that actually also is used by recent studies, but because it still works the way it is defined. The science-based industries are sectors where innovation is based on advances in science, pharma, electronic, and so on. Specialized supplies industries are sectors that produce machinery and equipment. Scale-intensive industries are the industries where scale economies are very relevant, so automotive and basic metals. And supply dominated are traditional sectors. So the science base is, let's say, a bit more complex than specialized suppliers, which is much more advanced than scale intensive or supply dominated. So we see how the capabilities of firms in these different sectors look like. So now I have all non-manufacturing together, and this is why you have the circle for the non-manufacturing quite big, because all the number of firms are higher there now. And we split the manufacturing into this four private sectors. And here we see a very nice and clear ladder. So we do these exercises also to confirm what we are seeing or what we're observing is not completely random, and it kind of confirms, or it is somehow or it is very much expected to see that the science-based sectors, the firms in the science-based sectors, have higher capabilities than the ones in specialized suppliers, which have higher capabilities than scale intensive and supply dominated. So this is something that we would have expected, and confirms that what we observe is capability structure of firms. So the first question that comes to someone's mind is, well, this might, which are the firms that with higher capabilities? So we saw some sectoral dimension. What are the firm characteristics? One might assume that bigger firms have higher capabilities. In fact, this is not really the case, because when we look at the relationship between this economic regression between log sales, the firm size, and capabilities, and you see that there is a positive relationship between size and capabilities only in the first stage. So we again put those lines for the capabilities, which are the 3 stages of the ladder. And the first stage, you see some relationship, but after that, capabilities and firm size do not have any relationship between the second in the second and the third stage. Now we look at, what does it mean to have higher capabilities? What does it mean to be positioned at, let's say, the higher stage of the capabilities ladder? So we look at what capabilities mean for firm growth. So what we do here, we already know from the literature that smaller firms grow more. So we look at the growth of firms in different size classes. So what we do here I show you the relative sales growth on the y-axis, and on the x-axis, I have split the x-axis into the different stages of the ladder again. And the different size classes are the different colors. So blue is the small size class, yellow is, or orange is the size class 1, and so on. So here we look at the growth of the firms that have been in the same size class, but in a different stage of the ladder. What happens after 7 years? So here the results that we see are quite strong, in the sense that for firms of the same size class, if they were in, let's say, stage 1 of the capabilities ladder, which is here, you see that their growth is much lower than the firms who were in a higher stage of the capabilities ladder. And there is a big difference between 1A and 1B, and this is also why we split it. So for the same size class, the firms initially, if it were in a higher stage of the capabilities ladder, this means that they will have 3 times higher the growth than their counterparts. So it's a very strong results that we see, that the effect of capabilities on growth of firms. This is some numbers of what I showed you. We have actually tried also for different sectors separately, and the results holds the same, that there is a big relationship, strong relationship between capabilities and growth. We also look at what happens, what's the relationship between capabilities and firm age. Here we couldn't see much, and we were also a bit puzzled by the fact that they don't really climb quite a lot. You know, they try to stay where they are. This talks a bit more that these capabilities might be not so easy to acquire, or it's more idiosyncratic that's in the firm. Now we also do some analysis, which is not exactly in the paper, but I will show you here. It's more test on what does actually firm capabilities mean, not only in terms of growth, but also in terms of resilient time. So we check at the COVID time, we check are firms with better capabilities more resilient, and we see that this is indeed the case, not only when we look at sales growth, but also in terms of firm exit. We also look at, let's say, the geographical dimension. So we look at how does the firm capabilities of different firms in different states look like. So we see that there are some variations, And some of the states with, let's say, good governance index or with better growth, that showed better growth, have also firms that with higher capabilities. Again, this is also not part of the paper, but I'm also showing this. It's also part of extension that we currently did. We moved from firms to regional production capabilities. So how much do average firm capabilities in a region explain the regional production capabilities? Now I'll tell you what is region production capabilities. Region production capabilities here would be how complex products the region is able to produce. So it's not based on activities, it's based on products produced by the regions. We make similar indexes as you see in the complexity literature to look at the production capabilities of the region. So we asked two questions. One, how much does the average capabilities in a region explain the region production capabilities? And how much do the top firm capabilities? So here, remember that the firm capabilities is a measure that's built on the basis of what firms do, which are the activities that they do. And the regional production capabilities are what the region produce in terms of the products, so harmonized system products. So when we look at the average firms or average firm capabilities, we don't see any relationship. On the y-axis, we have the firm average fitness, and on the x-axis, we have the state or the region production fitness. But when we look at the top firm fitness, we see that there is a very strong relationship between the top two firms, this is top two firms, the fitness or the complexity of the top two firms, and the state production capabilities. And we do this regression for different lags. Of course, there's a relationship. We cannot claim any causality here. However, we see that a lot of the region production capabilities are explained by the firm capabilities, even with the top firm capabilities, even when we have not only the contemporaneous, but lag from 1 to 5. So let me conclude what we have seen in the paper. So we see that the capabilities of firms by looking at the activities that they do can be arranged in a hierarchy, meaning that firms do activities following a natural order. It means there are certain activities that are prerequisites to other activities. It means that, for instance, a policy implication would be if one decide to give R&D subsidies to all firms in a sector, it might not work because there are some firms that are not yet ready to do R&D. So you can exactly identify which are the firms that are ready to do certain activities. And this hierarchy of capabilities, of course, we see that the activities are also, there are some activities that are more complex and some less complex, and this could change in time. The firms with higher capabilities have higher growth rates and better resilience to shocks. Firm capabilities also explain a lot of variance of regional production capabilities. And as I mentioned before, the work is useful in understanding which are the precursors and prerequisites for certain type of activities. So before this activity, you might want to do something else, and your next step is this. So this is the kind of information that it can provide. And the paper is available online as Unimerit working paper in the working paper series. I don't know how much time I took, but thank you.
Well, that's fantastic, Nanditha. Yes, that was a really concise talk. We had a couple of minutes left, but I think we could move to Anthony if he's ready to go, and that'll free up some extra questions for some discussion and some questions also I have. So Anthony, the floor is yours. Thank you.
Thanks, everyone. Hopefully you can see my screen and it works okay. Let me know if it doesn't.
Oh, Anthony, you're a bit off camera, at least on my
That's strange. On
my screen. Like it's not centered. There we go.
I'll just move my chair. That's pretty easy.
Perfect. Okay. Thanks much.
Thanks, John. Yeah, and yeah, you can see this, so that's good. So thank you, Nanditha, for the talk. Thanks, John, for chairing. Thanks to ESCoE for given me the opportunity to discuss this paper, positioning firms along the capability ladder. So a very interesting paper, an innovative paper, and something that's very interdisciplinary. So let me give a recapitulation from my perspective of what the paper does, and I'll give a couple of points on how I think other researchers can build on this research and how the authors may elaborate on it in the future. So key contribution is to use a novel methodology to measure and rank firm capabilities using this so-called nestedness approach, which takes inspiration from the natural sciences, from biology, genomics, ecology, and so on, and have been applied a little bit in the social sciences, and this is a new application of it. So in the paper, they take data from 40,000 Indian firms, which that ends up being a lot more data points because that's the number of firms, and they have 30 years or 40 years of time periods. And they create this so-called capabilities ladder. So a capabilities ladder is essentially a hierarchy of different firm capabilities, and you can locate firms along that capabilities ladder. So helpfully, they distinguish different aspects of the ladder. You've got low rungs, mid rungs, and high rungs. So at lower rungs, you have basic capabilities. So these are things like borrowing, owning land. In the middle of the capabilities ladder, you have firms that engage in internationalization and absorptive capacity. And at the very top of the ladder, you've got those firms that engage in innovation, more likely to be involved in environmental investment. So these types of capabilities. There's 47 capabilities in total. And then there's a dynamic aspect, so you can look at how capabilities have changed over time. Quite intuitively, ICT was a high rung or a mid rung capability in the past, but it's gone down as nowadays most people can use a computer and use ICT equipment. Most firms can do those things. And then, given this kind of descriptive exercise, which I see as the main exercise of the paper, there's then an application of the ranking. Once you have the ranking, it's used to explain growth and survival. So again, quite intuitively, high capability firms tend to be associated with higher growth. The survival one is a bit more nuanced. It can be detrimental for firms to engage in high-level capabilities too quickly. So yeah, the paper actually is positioning itself, and it makes it very clear in strategic management literature. So this is many people tuning in will be economists, and so the interests, I sort of have to remind myself that their interests are going to be different to ours as economists, and I think the goal is mainly to map a path for capability development, which might be useful for say a manager. With my sort of economics hat on, the big picture that we get from this sort of an exercise is we learn more about the black box of firms. So we learn more about how firms can be characterized and described with large data sets. So I'll give a very brief perspective on nestedness. I think Nanditha did a really good job of this, but my perspective is not the one from the paper. It's just the one that came to me when I was reading over it. So I knew nothing about this this methodology when I read the paper, and the crux of nestedness is to describe how complex systems are organized. So in a complex system, which could be an ecological example, or it could be an economy or firms, as in this case, complex elements will only be present in a small number of locations, while simple elements are present in many locations. So this would be simple capabilities are present in many firms, but the more complex ones are only in a small number. So I boil it down to a sort of, the way I think about this is, let's boil it down to as simple an example as possible, as simple a model as possible, and we can think of it as I've illustrated here. If you take a 3-firm model or a 3-firm economy, whatever you want to call it, you can picture what's going on. I've come up with 3 real life firms here, ASML, which is a very advanced firm that produces the technology that microchip producers use. So it allows you to essentially write on very small microchips. Carl Zeiss is a complementary company that produces the type of lenses you need to do this technology. And Nikon is a big lenses-based company that also has some advanced features. But what we should think of for this nestedness is that the total set is firm X1, X2, and X3, which is all three of these companies. But within that set, we have a subset, which is ASML and Carl Zeiss, that can do slightly more advanced capabilities. They have slightly more advanced technologies. And then within the Carl Zeiss and ASML subset, we have a further subset, which is just ASML, and they're a pretty unique company who can produce, who can use these lenses to produce a technology that allows us to write on very, very small microchips, and they're pretty unique. And other companies have tried to do it, but they haven't got that capability yet. So this is a simple example of how we can think about the approach that this paper is taking. And of course, it's not using three firms, it's using a vast data set which will apply an algorithm to give us something along these lines. One thing we have to sort of remind ourselves of when we take these methodologies particularly from the natural sciences, is the kind of perennial problem in any of the social sciences is that when we intervene in a system, the system often responds to our intervention, which wouldn't be the case, for example, if you're thinking of this in a genomics application where you might have a nestedness algorithm to understand particular genes that are associated with a certain cancer or something like that. Whereas, in economics, we have to always be, or in social science generally, we have to be very careful of how these kind of descriptive exercises should be interpreted for policy. And I'll explain a bit of that now. So the paper comes out with two sort of implications for managers and for policymakers. So the message for managers is you should focus on developing basic capabilities before advanced capabilities. And for policymakers, they should focus on policies that help to develop basic capabilities first. So as Nanditha pointed out at the end of her talk, you wouldn't want to encourage everyone to do R&D if they don't have the fundamental primitive capabilities in place in order to do good R&D. So they're the kind of two policy prescriptions. But we can sort of take these a bit further, and it certainly sounded through the talk that the authors are thinking of pragmatic ways to implement this and how to take it further than it is currently in the paper. So I'd be interested to probe a bit further on whether there's much evidence that managers are not doing this already. So is this a big problem, essentially? Are we seeing lots of managers who try to run before they can walk? Is there a lot of evidence that managers don't naturally acquire basic skills before they try to branch out to more sophisticated capabilities? And on the policymaker side, it's hard to know how policymakers precisely should intervene here. Like who should be in charge of this? Because it's not always the case that governments know well how to come into businesses and tell them how to manage. So it's not always clear what the exact policy is here and how it can be done in practice. And then, of course, we always have to ask, is the intervention even worth it? How much does it cost? And so on. But these are really interesting. The paper provides a really interesting avenue to go down and explore further. And yes, of course, these regression analyses are very interesting as well. So we could maybe take those slightly further and ask how much more growth would we expect, or how much better survival would we expect if firms' basic capabilities were improved to some extent. We do have to be sort of mindful of what I said closing the last slide, that these are really associations, and Nanditha said this, they're not really causal relationships. This is a description of how capabilities look, and then we're looking at how these capabilities are related to firm features like growth and survival. But you know, there's always the possibility that a firm grows because it has good capabilities, or it vice versa, it acquires capabilities because it is a growth firm. Am I okay for time, John? I can hear a mic going. I don't know if that's
Oh, you've got a couple more minutes. Please continue. It's a great discussion.
okay. So this is my last one anyway, so it'll only be a couple of minutes. Yeah, so this is a bit wonkish. I'm sorry about this one. So the one is for whoever is the kind of computational lead on all of this. It would be interesting to know how this algorithm performs in different scenarios. So are there specific tests or benchmarks? So we just apply this one algorithm, which I understand is a very frontier algorithm and has been used elsewhere successfully. Often if we introduce a new methodology in, say, a time series econometrics or something like that, one would benchmark it against a well-known performer, like a AR1 model or something like that. I don't know if there's something equivalent in this literature, but maybe that is something you have thought about. I know that in this well-known sort of econ social science paper here, Dalgo and Hausman, they use a nesting algorithm, but they take a linear approach, which I understand won't get all of the sophistication that you've got. But the question is always, how much do we actually lose for going more sophisticated? So that's my wonkish point. And yeah, we can take this concept much further than has been done in this paper. So this is a great paper, opens many doors for future research. I thought maybe, you know, apply the algorithm by industry. So the industry stuff you've done at the moment is when you put the whole data set to work and you get your ranking, and then you break down by industry, having performed the algorithm. It would be interesting just to take the algorithm and apply it to different industries, because we would be you know, expecting that capabilities in some industries are more important than in other industries. So the ladder could differ across different industries, which would be informative. And of course, this is applied to one country, India, on a rich data set. But the kind of data you're using is not unattainable in many other countries. So it'd be really good to do this for a larger set of countries in you know, in future papers, and so on. The basic ingredient is just information on where firms are investing, essentially, to know what their capabilities might be. So that's everything. I had one thought that came up to me during the talk, which was when we saw this sort of plateauing profile, when you're looking at the comparison of the capabilities ladder to survival or growth. A probable reason for this is that when you do your algorithm, it's this, you input the data in a binary way. So it's you know, you just have a 1 if a firm invests in a certain thing, and a 0 if it doesn't invest in it. And you've got lots of these 1s and 0s for all these different types of capabilities or things that you can invest in, these types of expenditures. So the fundamental data set is a binary data set, it's 1s and 0s. So because you don't have that continuity of larger firms perhaps investing a lot more in certain inputs, you might be just losing the effect at the upper end of the tail, which you would capture if you had a more continuous measure of the amount they're investing in different things. So that's a possible reason why you're observing that, that might be worth investigating a bit further. But yeah, overall, thank you very much. It was a great opportunity to read this paper. I think I can learn some things and put it in some things that I'm working on, which is great. And yes, first paper to quantify these capabilities in this way, so it's very fundamental, and it opens lots of doors for future research, which is always the hallmark of a great contribution. So thanks very much.
Thank you so much, Anthony. John, can I first respond to whom?
Yes, please do respond, and then we're going to open up the floor to questions, folks, which you can either raise your hand or we have a Q&A box if you want to join in there. So yes, please.
Okay. So let me try to go back not in a order by which you asked, but in the order that I think the discussion would be interesting. So first, I would try to. There's a minor point that maybe I didn't get it when you told about the examples of the ASML and the Nikon on Carl Says. I must clarify that the nestedness is not on the firms, but on the activities that they do. Yeah. So just to clarify. So talking about the policy implications, so I would start with that, because I found it a very interesting question. So we have, and also the question on, do managers already do this, right? So we have had quite some interest from policymakers from India to Philippines to the Commission to the World Bank. So I just give you one example. So let's say the International Finance Corporation wants to fund firms to do certain activities. They know which firms to fund for. So if you think on the lines of the industrial policy, because they know which firms have the prerequisites to do certain activities. Now, do managers already do this? I mean, if you look at just the case of India, the export subsidies was something that made many firms do export, and they were not yet ready for export. So there were export subsidies that said, if you have this much of sales, if you have this, if you have that, and if you belong to the sector, you can have an export subsidy. So let's managers that let's start exporting. And this is also why when you start looking at, do efficient firms enter the export market, and many of these questions that are really answered for US and for other economies by Bernard Jensen and so on, it's very difficult to observe these results for India, because there are also non-productive firms entering the export market. So it's a huge waste of resources for the. So do the managers actually do this? I'm in doubt. I'm in doubt. You know, the same with R&D. If you this was a follow-up paper of another paper of ours with the same authors that we published. What's good for the goose is not good for the gander. Heterogeneous capabilities and R&D performances that was published in Industrial and Corporate Change, where we showed that not all firms benefit from R&D. So there are some firms that benefit from R&D, and one should make an assumption of fully rational firms and fully rational managers to make sure that, you know, they already know that they are spending on the right things. So this is one example of how a policy intervention would look like. So in terms of when you're thinking about where to invest, or when you're thinking about making certain investments in industry, you can identify the firm. So it goes on the lines of the industrial policy. It's true that
Could we have 5 minutes left? So I just want to make sure that anyone who has any questions gets a chance to ask them. So if anyone does have any questions or comments in the audience there, please raise your hand. We can go over an hour if you need to, but or in the Q&A box. We'd love to. I want to make sure people get a chance to do that. In the meantime, in case there aren't any, I mean, I thought this was a really fascinating paper. It stirred up a lot of questions for me on measurement, also the dynamics of capabilities. I thought it was quite fascinating in that some capabilities which are originally important in an ecosystem become less so over time, right? And so I think in connection to policy, thinking about exactly, we have a question, that'll be great. You know, thinking about indirect subsidies, for instance, that are kind of incentive compatible with people actually using them in a proactive way. So in your example of them being beneficial for exports, where they have to pay something to access, say, a subsidized resource, it's not just given to them, could be a way to kind of naturally winnow out which capabilities are important. We have a Meng. Could we have a question from you?
Yes. Thank you very much for a very interesting presentation. I'm wondering, I'm not quite sure if I get it right. Do you mean for the hierarchies? Do you mean that firms have to do that in order before they can achieve maturity, or do you think in your sample there are firms that skip the first 1 or 2 stages and then go directly to the third stage? Because I'm thinking about firms that are acquiring R&D capabilities from external sources.
Nanditha,
Yeah. Okay. Yeah. So the point that I was trying to convey was that firms do not skip or do not necessarily jump, in the sense that when we see that the firm is doing complex activity, it has done also the, let's say, less complex or simpler activities before. On the question of R&D capabilities, yes, we see that there are certain activities that are needed before they do R&D, and we see that firms do them, or the ones that have survived do them. Now, on our sourcing of R&D from outside, I think we do have like one variable that we look at the outsourcing, but I'm not necessarily, and we also look at royalty and technical know-how fees paid, but I need to check if we do have the specific variable. There's something that kind of capture the external knowledge. I mean, in a way, one could also think of import of machinery as a knowledge transfer. So there are many elements that could come within the knowledge transfer, if that's what you mean. It doesn't have to be that the firms themselves have an R&D lab. And these are some of these activities come within the second stage together with the R&D. And this is not something that we decided, but the data decided. I mean, that's how they do it. So yeah, it is possible that there are other forms of knowledge transfer that they do that is not necessarily R&D, but this comes together with the R&D activities. So
okay, that's great. Thank you so much. Thank you.
Okay. Well, if we don't have any more questions from the audience, we're just at like 1 minute left. So just to make it concise, I want to thank ESCoE for putting this on. I want to thank Nanditha for a really fascinating, innovative talk. I know it's kind of early stage in terms of the kind of data, but I think that this line of research could definitely expand as we record more things about firms and think about what kinds of questions we actually want to ask firms, which is something that many of us are already involved with, such as Anthony. And thank you very much, Anthony, for a fantastic discussion full of great real-world examples and diagrams. I always appreciate that. So with that, I'd like to thank everybody, as also Sarah for helping to organize this, and say goodbye for now until the next ESCoE talk.
thank you so much, John.
Thank you. Goodbye.
Bye.